Linux Essentials. In this video, we're going to talk about X-Windows, shell scripts, and LILO, the Linux loader. Three very powerful features of Linux. Let's start with X-Windows. X-Windows is a hardware-independent, network-based Windows system. It's not a graphical user interface by itself, but very powerful GUIs can be built on top of X-Windows. We're going to talk about the different desktop environments and window managers that you can choose from, and how to configure those so they do exactly what you want. And then we'll move on and talk about shell scripts. We already know what a shell is, right? Like the bash shell. The shell allows us, the user, to interact with the kernel by typing commands. And shell scripts are basically just collections of those commands, but they also allow us to loop so we can do things over and over again, and test conditions so we can execute certain commands only when certain conditions are met. And that makes it a powerful sort of mini programming language. And then we'll talk about LILO, the Linux loader. When you start your computer, the first thing that kicks in is what we call the BIOS, the basic input-output system. And that checks your hardware to make sure it's functioning correctly. And then a bootloader takes over to start up an operating system. And LILO is a bootloader, and it's capable of booting Linux. And we'll talk about some configuration options for LILO. So let's get started. There's three major components to X Windows. There's the X server, the window manager, and the desktop environment. The X server is responsible for the raw graphic output to your screen, the character placement, the pixel placement in a picture, that kind of stuff. That's what the X server does. X386 is the name of the X server, and you can find out all about X386 at this website, x386.org. The latest version of X386 is 4.0 point something. Now the window manager, that's responsible for taking that raw graphic output and putting a border on it, a title bar. Now that might seem like fluff, just the border and the title bar, but really that's what controls the look and the feel. We click on that border and we drag it, that resizes the window. Or we click on the title bar and we drag it, that moves the window. Or we click on those icons in the top corner and that minimizes the window or deletes it altogether. Okay? So that's what the look and the feel is of the X Windows system, is in the window manager. Now the desktop environment, that's sort of one step larger. When you think about a Macintosh or a Windows operating system, it's not just the window manager and moving the windows around that really distinguishes the operating system. What distinguishes it is all those graphical utilities and configuration programs. In Windows, you can point and click and set up everything. Your microphone volume, your screen resolution display, everything like that is just set up in some graphical configuration program. And the Linux desktop environments have those abilities as well, have those utilities and configuration programs. The most popular desktop environments you'll hear about are KDE, which is the K desktop environment. There's GNOME, which is the one I'm using. There's CDE, which is the common desktop environment. There's some other ones. The most popular window managers are KWM for the K window manager. There's Sawfish, which is the one I'm using. There's ICE window manager. And again, there's more of these. You can experiment, look out on the web, see which ones there are, download them, try them out, see which one you like the best. You know, they're all useful. They all have little bit different traits, but they all basically do the same thing. Like I said, the window manager provides like that look and the feel, and the desktop environment provides all those configuration programs and graphical utilities. So let's go and experiment with our X Windows system now, and I'll show you where some of this stuff is. Okay, so let's take a little tour of some of these configuration tools. Down here under the GNOME main menu, I click on that. I go to Programs, I go to Settings, and let's look at a couple things in here. Let's look at Desktop first. The desktop, the various menus in here, the background is just that blue background, and you can change that. The screensaver, what comes on when you're idle. The theme selector is kind of just like a general color shading scheme, what clicked on windows look like, what non-clicked on windows look like. The fact that this thing up here right now says that is kind of gray, that's part of the theme selector. When I click on it, it turns blue. That's so on, stuff like that. Under Window Manager, that's where you can choose your window manager. Under Panel, you pick things like, when I move my cursor around, you see how these things light up. That's part of the panel description, okay? Under peripherals here, we can change properties, CD, keyboard, mouse, repeat rate, stuff like that. Down here under Sawfish Window Manager, I can change all sorts of stuff. One of the first things that you can do is sort of the meta adjustment. It says, what kind of user are you? Are you a novice, an intermediate, an expert? I would say check it at least so it's intermediate, and maybe even expert, even if you're a new user, because then at least you see all the different options that are out there, and you can configure it so it works just like you want. Okay, then there's the appearance, how windows look, focus behavior. I like to set it up so that when I move my mouse into the window, it focuses, meaning that I can type and my characters will appear in that window instead of having to click on the window to focus it. And you might say, wow, that's really type A, but it's just something that I've learned over time, and I really like it, so I always set up my focus that way. Okay, and you do have that option. If you don't care, don't worry about it. It's no big deal. But the fact is, there's all these configurations here, and you should do it just the way you like it to work. You can set it up to minimize and maximize windows. You can move and resize windows. You can change those properties. Placement, like where a window comes when you open up a new terminal. Where should that be? Should it be centered? Should it be justified to the left or justified to the right, and so on? What kinds of sounds should appear for certain kinds of events when you close a window or when you do something, when you make some error? And then there's workspaces. Workspaces are like different screens, really. Like it's all on the same computer. But say you've got a bunch of windows open and you're working on some project, and then somebody comes to you and says, hey, I need my password changed. Okay? And then you say, well, geez, I'm right in the middle of this. You don't want to close all those windows and get in the way of that. So what you can do is you can go to a new workspace and then do that thing there. Let me show you how that works. Over here down in the very right bottom corner, if I click on this other button, that takes me to a new workspace. So I can open a new window in there. I can do something. I can become the root user. Okay, and I can do something in there. And, oops, did that wrong. And, but you get the idea. So I go to this new window, and I do a listing over here. Okay, I do something over here, and now I'm done, and I can go back to that first workspace, and that's where I was originally. Okay, so the workspace idea, it's just sort of like a little bit of an organization tool, so you don't have to get too cluttered with too many windows working on something at once. Okay. Now another thing down here under the settings is the menu editor, so you can change what comes up in this menu here. Okay, so if I go to the menu editor, you'll see, okay, reading all the menus, and now I'm in the menu editor, and what I can do is I can change what comes up under the settings menu. Okay, so there I am under the settings menu. There's the Sawfish window manager. There's all the stuff that was in there. If I find that I don't ever change some of these things and I think it's too cluttered, I can take some of those things out. Okay, again, that's all configurable. It's all up to you. Alright, so that stuff that we just did, that's to configure the look and feel, what items are in the menus on the desktop, how the windows focus, things like that. And if you need to configure something at a more low level though, you have to change the XF86 config file. And one of the tools that you can use to do that in Red Hat is called Xconfigurator. You have to be the super user to use it, so I'll switch over first. And then it's a capital X followed by configurator. And you type that in, and like I said, it's changing the XF86 config file. And that's in the etc x11 directory, probably. It could be in user x11r6 lib x11 as well. And if you're going to do this by hand, if you're not going to use Xconfigurator or you don't have Red Hat, I would suggest at least looking around to see if there is a graphical X Windows configuration tool. And if there's not, then go ahead and just edit it manually. Certainly read the README file first, because it'll tell you what all the different sections of the config file are for and how to alter them and so on. Okay, so again, this is like the other ones that we've seen. You tab through, and I'm going to hit spacebar to say OK. And now it says choose a video card. Okay, so I'm going to page down here and pick a video card. If you don't have one, you can pick unlisted card, and then it's going to do some sort of generic selection there for you. And here's my card here, NVIDIA GeForce 2. I'm going to set tab to OK and hit spacebar. And now it says what kind of monitor do you have. Again, I'm going to have to page down because I don't have an Acer monitor naturally. That would be too easy. And I'm paging down through this. If you don't have a monitor that's in this list, which would be pretty hard to believe because the list is pretty long as you can see, definitely choose custom, and then you have to manually enter your refresh rates. And don't mess up there. Don't enter them too high, because then you could end up damaging your monitor. Okay, so be careful. Look at the refresh rates in the manuals. Make sure that you understand exactly what kind of refresh rates they're talking about, and don't choose maximums. Choose the standard ones, and you'll be okay. If your monitor is in the list, like mine is here, the Philips 107S, then again you just choose OK. And now it's going to do the screen configuration. Now what they do usually is you probe this, and then it'll get the best sort of video mode and color depth for your computer. Alright? I'm going to choose don't probe because I don't want it to go on. It says here that it could lock up your system. I've tried it and it doesn't lock up my system, but it does sort of flash wildly and it looks really bad on the video. So I'll just say don't probe here. but you could probe if you wanted to and try it out. So then it's going to ask me to manually enter some of this information. I'm going to say OK. It says don't choose no clock chip setting is recommended. So again, I'll choose that. And then it says pick some resolutions here. And again, for this video stuff, I've been doing pretty low resolution stuff. And again, I'm just going to say OK here. And now it says it'll start to test your X configuration. Again, I'm just going to skip that because I don't want to go through all that. But I think I've walked you through it enough that the idea makes sense here. So again, I'm going to skip that. And it says, OK, now your configuration files have been written. Take a look at it and make sure that it does what you want it to do. And certainly check out this readme.config file to get the full explanation of what's going on in there. Okay, so I'll just say OK here. And now X Windows would be reconfigured if I had bought a new video card or a new monitor or something. All right, so let's talk about shell scripting for a little bit now. A shell script is basically like a mini program that's composed of shell commands. Shell commands that we already know. Things like cat and useradd are examples of commands that we can use in a shell script to automate some task. And scripts are great for repetitive tasks because then you don't have to remember all the different commands that you need to accomplish some task, and you don't have to type them in. If you're like me, I'm a slow typist. So when I use a script, it saves me a lot of time. We can use scripts for things like backups or starting up your computer or adding users. And actually, there's already a script in place for starting up your computer. So it's good to understand shell scripting because we can write our own scripts to do things like backing up our system, or we can modify scripts that are already in place, like those for starting up your system. And it's good for inexperienced users because if they want to accomplish some hard task, they don't have to know all the different commands for that task if there's a shell script in place that does it. All they have to know is how to operate that little shell script, which is really easy. So let's move over to the Linux screen and do some shell script stuff. So let's start with the fundamentals of shell scripts. We'll learn what every shell script must have, and we'll also learn how to execute a shell script. Now I've created this subdirectory of my home directory called scripts, so we'll go in there to work. Okay, and I've got my Emacs editor down here minimized, and we'll use the Emacs editor to create our shell script. Now let's get a new file going, and remember, you specify that file with the Control-X, Control-F commands, or you go under the Files menu and you say Open File. Okay, and remember, tilde specifies my home directory, so tilde scripts is my script subdirectory, and I'll say tilde scripts, and then I'll specify the name of the file that I want to create, and I'm going to call it demo1.sh. Now every shell script should end with the .sh extension, which just stands for shell. So I'll hit enter here. Now you can see the name of this buffer is demo1.sh. It's a new file. Emacs is telling us that. And Emacs is also smart enough to know that it's a shell script because we called it with the .sh extension. So we'll use the special formatting for shell scripts. Okay? So now every shell script must start with what we call a shebang. And a shebang is just a fancy name for a sharp sign followed by an exclamation mark. And after the shebang, what you do is you put the path to the shell that you're going to use. Now I'm going to use the bash shell. That's certainly the most common shell in Linux, the most common scripting language in Linux, and that's the shell that I'm going to use. Occasionally you might see a script that starts with shebang/bin/sh. But I'll bet that bin.sh is linked to bin bash on your system. No Linux systems use the bin.sh shell anymore. You can determine for certain if you go into the /bin directory and you do a long listing, I bet you'll see that the bin.sh shell is linked to bin bash. Now this is a special line. This is the shebang line. Okay? But any other line that starts with a sharp sign is what we call a comment. And a comment is just a note to the reader, telling them what the script is, maybe how to use it, that sort of stuff. Okay, so this is just going to be a short script, so I'll just write this as a silly script. Maybe in the comments at the top, you would write the author of the script, when it was written, the revision history, when it was modified, what modifications were made, and so on. Certainly, if it's a long script that a lot of people are using, you should definitely have a revision history in there so that if you change the way it's working, that people know that and they can just look in the comments and see that. Okay, so the first command that I'll write in my script is the echo command, which is just a print statement to the screen. So I'll write, this is a script, and everything here between the double quotes will be printed out literally to the screen. Okay, maybe I'll write another echo statement that says, what do you think? Okay, let me put a space in there. And again, everything in between the double quotes will be printed out literally to the screen. Now you can also put a comment on a line with some code if it's at the end of the line. So once that sharp sign happens, then the rest of the line is a comment and will be ignored when I execute the script. Okay, so I'll say this is also a comment. Now when I execute the script, all the comments, this one and this one, will be ignored and all the code will be executed. Okay, so now let's save this file, and remember you can do that with the Control-X, Control-S command, or you can go under Files and say Save Buffer. Okay, so now you can see down here we wrote demo1.sh, so let me minimize this window, and now we're out at the command prompt again. So let me do a long listing in my scripts directory, and you'll see here the demo1.sh program that we just created and wrote, and you can also see over here the permissions for it. Now note that there's no execute permissions set for this file. Okay, now let me show you two different ways to run this script. One way is you can say bash followed by the script name. Okay, so bash demo1.sh will run the script. If I hit enter, there's the output for the script. Okay, just what we thought it should be. Now another way to run a script, and probably the more common way to run a script, is to say // followed by the script name. Okay, so this works if you're in the current directory. That's what // says. // says specifies the current directory, and then you follow that by the script name. Now if I hit enter here, you'll see that I get a permission denied error. And the reason I get that permission denied error is because there's no execute bits set in this permission string. So let me change that. So we'll change it so that everybody can execute this script. Okay, so I'll do that, and now I'll say /demo1.sh, and now it will actually run. Okay, this is certainly the way that I do it more often. It's probably the way that most people do it more often. If that's your style, make sure that the execute bits are set in the permission string, or else you'll get this permission denied error. Now let's look at my second bash shell script. This one uses what we call variables. Variables are just things that hold data or information. And there's two kinds of variables in some sense. One kind of variable is passed into the program when you run it. For instance, if I type demo2.sh to run the program, and then I put a space and follow that by my name, Perry, then Perry is actually a variable to this program. It's sometimes called a parameter or an argument to the program. And the first argument or the first parameter of the program is referred to as $1 when you're inside of the program. So here, if I type demo2.sh space Perry, then $1 will represent Perry, will be the value Perry, and then this echo statement should print out hello Perry. Okay? Then another kind of variable is what we call local variable. Now a local variable like here, number 1, is being assigned the value 234. On the next line, the local variable number 2 is being assigned the value 456. Now if I want to add these two things up and then store them in a variable called number 3, I have to use the let command, and then I say let number 3 equal $number 1 plus $number 2. The reason I have to use dollar signs here is because I want the value of the variable substituted into this expression. Okay, so $number 1 is the value 234 and $number 2 is the value 456. They're going to be added here together, and the let statement says evaluate that expression and then store the answer in this, number 3. Now if I want to print out the value of number 3 to the screen, I've got to say the answer is $number 3 in my echo statement. Okay, again, the dollar sign says go get the value of that variable and substitute that into this expression. If I didn't put the dollar sign there, what would happen is it would say the answer is capital NUMBER3. Okay, it would just be some word that it would print out, and it wouldn't think that it was a variable and that it had to go get the value of. The dollar sign forces it to go get the value of the variable and substitute it in. All right, so let's go out here and run this script and see what it does. Okay, so I'll say /demo2, I'll put a space Perry. Okay, and it says, hello Perry, I hope you're having fun. The answer is 690. And if I did the same thing again and I put a capital P there, then again, the capital P-E-R-R-Y would then be translated to that variable, and that would be printed out to the screen. Okay, so you can kind of see how variables work now. Now let's do a third script, but before we do that, I just want to show you a couple things. Let's make a script that can take a set of usernames and show for those particular usernames how much disk space they're using in their home directory and below. Okay, so remember the du command that we've looked at before. If I do the du command in, let me go up one level here so I'm not in my scripts directory. If I do the du command there, it does this whole listing of stuff. And remember, the du with the -s option does a summary. And so it says there's 1,400 kilobytes of space used in the dot directory, meaning the root directory of where I'm at, the Perry directory. Okay, so that's sort of going to be the essence of our script. We're going to use this du-s command so we can get this information, and we're going to print that out to the screen for each username that's input. Okay, so let's look at the first approximation of this script, and then we'll do another refinement of this script in a second. So now this script uses a conditional statement. Okay, a conditional statement in the Bash shell scripting language is signified by an if, a then, and a phi. The phi is just if spelled backwards. That just signifies the end of the if statement. Okay, now what happens, let's talk about the structure of this, and then we'll talk about the meaning of each piece. But first let's talk about the structure. This is a conditional expression. If this expression is determined to be true, then all the stuff in between then and phi is executed. Okay? If this stuff is determined to be false, if this conditional expression is determined to be untrue, then all this stuff is skipped, and then I do the rest of this stuff. Okay? So now let's explain the details of what this means. An important thing in a conditional expression are these square brackets, and they've got to have spaces around them. Okay? You can't butt up and get rid of these spaces in here, or else it's not going to be interpreted correctly. Okay, so the square brackets is an important part of the conditional expression. And now let's look at the individual pieces. The first piece says if $$sharp, okay, $$sharp, that's another special variable. Like $1 represented the first argument passed into our shell script. Well, $sharp says how many arguments are passed into our shell script. Okay? Then there's a -LT. Well, -LT is the less than operator. So this says if the number of arguments passed into our shell script is less than 1, then I'll do this stuff. Now let's look at what this stuff is. The first thing here is this echo statement that says you must pass at least one username to the $0 script. Okay, well what's $0? That's another special variable, and that's the name of the script. Okay, so we're learning all these special variables in the Bash shell scripting language. $1 is the first argument, $2 is the next argument, $sharp is just the number of arguments, and $0 is the name of the script. Okay, so if the number of arguments is less than 1, I'll say you have to pass at least one argument to this script, and then I say exit. What the exit statement does should be pretty obvious. It just stops running. It exits out of the program. It doesn't execute any more lines of code. It's just finished. Okay? So that's what this is saying. Now, if the number of arguments is not less than 1, if this statement is false, then it skips all this stuff, and it goes down here, and it says cd to /home/$1. The first argument that got passed in, I cd to the home directory of that user. Okay? And then what I do is I say, I set up this variable called space, and I say that's equal to du minus s. Now remember, let's look back again. Remember when we did the du minus s command, there were two fields in there. The first field was the number of bytes that that was used, and the second field was like the name of the directory. The dot directory meant the current directory. Okay? So now, if we look back in here, so I'm doing that du minus s, but I'm piping that into this new command called cut. And you might not have seen this before. The cut command, what that does is it says, takes out, or it cuts out a piece of this thing over here that is being piped into it. And the -F1 says cut out the first field and just display that. Don't display fields 2, 3, 4, however many there are. Just show the first field. So if we go back to this window, it will only show the 1400 part. And that's what I want, because in this next echo statement, I'm going to say $1, that user that I CD'd into their home directory, that user is using space kilobytes. And I just want that space to be 1400. I don't want it to be 1400 space dot kilobytes. That would be confusing. So that's why I cut out and only use that first field. Okay, so let's use this script. And then, like I said, we'll refine it so that we can do it for a whole bunch of users. Okay, so let's see if we can use it. I'll go down into the scripts directory again. And now what I'll do is I'll say ./demo3, and then I'll say Perry. Okay, now I do that, and it says Perry's using 1400 kilobytes. Okay, that's exactly what I wanted to have happen there. But now, remember, like we also had that special if statement at the top that if I didn't type in a username, that it would give out that nice error message, right? And it wouldn't just say like blank is using blank kilobytes. It would actually have some meaningful error message there. So let me try that. And it says, oh, you must pass at least one username to the demo3.sh script. That's perfect, right? Because somebody using this for the first time might not realize that they have to pass the usernames in, and so this tells them exactly what they have to do. Whereas if we didn't have that error message and it just said blank is using blank kilobytes, the person would sort of be clueless on how they should proceed to make this thing work correctly. Okay? So I like this error message for that reason. Okay, so now let's refine this script so that we can do it for a bunch of usernames. So the person using the script could say demo3.sh Perry, Alice, Bob. So all three of those users would then have their space usage printed out to the screen. Okay, so we're not going to change any of this code up here. If the user doesn't put in at least one username, then I'm still going to print out this message, you have to use at least one username. Okay, and I'm really not going to change any of this code either because it works nicely, right? It prints out exactly what we want to have printed out to the screen. The only thing I want to do is I just want to repeat this 3 times. Okay, now the thing that I'm going to do here is I'm not going to just copy and cut and paste this code and do it 3 times. That would be one option, except that wouldn't work very well if I had to do like 1,000 people, right? Or sometimes I wanted to do 3 and other times I wanted to do 10. Okay, so what I want to do is I'm going to enclose this code right here in what we call a loop so that it's executed multiple times. And each time through the loop, it works on the first, if I pass in 3 people like Perry, Alice, and Bob, first time through the loop it does Perry, next time it does Alice, and next time it does Bob. Okay, so let's refine this. Let's move over to my demo 4 where I've already done this. I'll move over there and let's look at this. So like I said, this stuff, I haven't changed this stuff, right? This is still the first beginning part. And you can see here, these 3 lines of code are still exactly the same. All I've added is the while, the do, and the done, and then the shift command. Okay, so first let's explain the while loop. This is a looping mechanism, okay? Like the if statement was this conditional mechanism, the while loop is like the if statement in that it starts with this conditional expression. And if this thing is true, then everything in between do and done is executed. Okay? If this thing is false, then all of this is skipped and then we move on. Okay? Just like the if statement, the only difference is if all this stuff is true, we go in and do all this stuff between do and done, and then when we get to the end, we go back up to the top and we test this again. And if it's still true, then we do all this stuff again. We get to the end, we go back up and we test. Is it still true? Yeah, well, we'll do it again. Okay? And we'll keep doing it until we go back up to the top and this is false. And finally, when it's false, then we'll skip out and do the rest of the code. And in this case, there's no extra code, so that would just end the program. Okay? So let's break this down and see what this does. Let's look at this conditional expression. The conditional expression says while $sharp, the same thing that we used up in the if statement, while the number of arguments -ge means greater than or equal. So while the number of arguments is greater than or equal to 1, do all this stuff inside the do and the done. Okay? And if this is not greater than or equal to 1, we'll skip it. Okay, now the $sharp says that's the number of arguments. All right, what you have to be careful of with a while statement though is that if that expression there is always true, it's never false, you're going to execute this code over and over and over and over and over again, and you're never going to stop executing it. It's just, if this is always true, you're just going to do this in what we call an infinite loop. Okay, and you don't want that because that's just going to hog up all the resources on your computer, and you don't want to do that. You're going to have to kill the process to stop that. Okay, so you want to make sure that this condition will eventually be false. And this is why it will be false, is this shift command down here. Okay, this shift command, what that does is it takes all the arguments like $1, $2, $3, it takes all those arguments and shifts them one over. Okay, that's why it's called shift. So what happens is after the shift command executes, $2 becomes $1, $3 becomes $2, and so on, however many arguments you have. But $1 is moved over and it's lost. So if I needed to use $1 again later in this program, the shift command would not be the way to go because I'd lose it. Okay, but I don't need to use $1 again in this program, so the shift command is going to work perfectly for me. Now the other thing that the shift command does, besides sliding all these things over, is it changes $sharp, the number of arguments there, from 3 down to 2, for instance. So if they passed in 3 usernames to this at the beginning, then initially $sharp is going to be 3. I'm going to go through the loop once. The shift command is going to take effect. Everything's going to slide over. And the next time I come up here, $sharp is going to be 2. I'm going to do the stuff again. I'm going to come back up. Then $sharp is going to be 1. I'm going to do this stuff again. I'm going to come back up. Then $sharp is going to be 0. This is going to be false. And then I'm going to kick out of the loop. Okay, so you see what's happening here? So each time through the loop, $1 is actually a different parameter or argument that was passed in. The first time it's actually the first one, next time through the loop it's the second one, next time through the loop it's the third one. Okay, so let's go out and run this and try it out. Now to run this, you're going to have to be the root user because we need to cd into other people's home directories. So I'm going to say ./demo4.sh, and I'm going to say Perry, Alice, Bob. Okay, 3 users. The first time through the loop, Perry will be $1. Next time through the loop, Alice will be $1 because the shift will like slide everything this way. And then the next time through the loop, Bob will be $1 because we're still shifting. And the shift is kind of like to the left in this picture. Okay, so let's do that and see what happens. And perfect, there's the answer. Perry's using 1416 kilobytes, Alice is using 52, and Bob's using 56. Okay, so there's the epitome of shell scripting. We get to use some program and say I want it to run this every day because those 3 people are running these scientific simulations that are eating up a lot of space and I want to make sure they haven't gotten out of control. I can just run this script every day and I don't have to run these individual commands to do it. I just set the script up and then I go out there and I just run it by saying demo4 Perry, Alice, Bob. And what's more is it's completely flexible, right? I can do the same thing as I did up above, but I could take Bob off the list and it still works nice and the output is still clean, okay? Or I could do the same thing and I could put Bob and Candy on the list, okay? So again, I've got all the output and it's nice and clean output, so it's a completely flexible script. It just loops for every input that I give it and it does that command, that little set of commands for each of these users that I list. Our last topic for this nugget is going to be a little discussion of LILO, the Linux loader. To understand what LILO does, let's talk a little bit about what happens when you turn on your computer. When you power up your computer, the first thing that happens is the BIOS starts, the basic input-output system. And what that does is it goes around and it probes some hardware. It checks to make sure your memory timing is correct and your devices are plugged in, stuff like that. And when all those tests pass, then what the BIOS does is it goes to the master boot record on your disk. Now, the BIOS knows where the master boot record is, like you know where the light switch is when you walk in your dark living room or something. Okay? It just knows where it is, it goes there, and it looks for a bootloader in the master boot record. Now, one of the bootloaders that could be there is LILO. Okay? And we can look at the configuration file for LILO. It's in the etc directory. On most systems, it's called lilo.conf. On my computer, it's called lilo.conf.anaconda on this Red Hat system. So we'll go in there, and the top part here is just like some basic LILO configuration options, and then the bottom part here would be one entry for each operating system. Now I only have one operating system here, so that's why there's only one entry. But if I had Linux and Windows or multiple versions of Linux or whatever, they would all be listed here in a separate little paragraph. And the options up here, what these say is the prompt option says that LILO should prompt me when it starts up and give me a choice of which operating system I want to start. The timeout says if I wait too long, then it's just going to go ahead and boot the default, which is Linux, and that's what this label is down here, also Linux. That's what ties these together. Now the timeout here, this is 50 decaseconds, which is 5 seconds. I don't know why they use decaseconds instead of just plain old seconds, but they did, so we'll live with it. It's no big deal. The boot option here, this says that it should boot off the first SCSI disk. SDA is the first SCSI disk. Okay, so that's what these options are. We can set these options with the LILO command. And if we do a man on LILO, you'll see all the different options there. There's the -D option to set that delay or that timeout. And you can set all the other things through here as well. Now you might not have LILO as your default on your system. Maybe you have Grub, which is the Grand Unified Bootloader. They basically work the same way. Grub's something a little bit newer. Maybe it's going to be a little bit more advanced and accept it. Right now I think LILO is probably more common, whatever. It doesn't matter. They both kind of do the same job, and configuring them is basically the same task. But it's good to be able to have multiple operating systems. Sometimes people want to have multiple versions of Linux. Maybe one is a more experimental version. They want to try that out before they commit to it, and they keep their old version, which is more stable, and they can use that. So LILO and Grub have many options and many advantages for people that want to experiment or have different operating systems on their computer. All right, well, it's time to wrap up another nugget. This is the nugget that I call Linux Essentials. First, we touched on X Windows. We talked about the X Server, X386. We talked about the various window managers and desktop environments that were out there that you could use. We also learned how to configure those through the graphical configuration tools that are available in Linux. We also talked about a Red Hat tool called Xconfigurator. Now that was more of a low-level tool. Like if you bought a new video card, you would use Xconfigurator to configure your system for that. And then we touched on shell scripts. And this really was a tip of the iceberg discussion. I mean, I tried to give you a little bit of depth and show you how useful a shell script could be, but there's a million times more out there. There's 500-page books written about shell scripts. So there's no way that you should expect after a 10-minute introduction, if that really was your introduction to shell scripting, that you should be able to go out and write any kind of shell script that you want. But hopefully I whetted your appetite enough that you'll go out there and learn some more about it. I mean, it's to the point where I still learn about shell scripts, and I wrote my first shell script back in the 80s. And then we talked about LILO, the Linux loader. We talked about the configuration file for LILO, how you can manipulate that, how you can set that up so it can boot multiple operating systems. Well, I hope you found this nugget informative, and thanks again for viewing.